Welcome. This video will be an overview of what OHDOT has set up as a starting point for end condition templates that are in our default template library. So if you have been using them, then you might notice that there are quite a few end condition templates to start out with. So what I did is I went through and I've updated. I've kind of gotten rid of some that we didn't really need anymore. And the main point of the update is to be more consistent across all of the templates to make sure that they connect between drop locations in all situations within reason. And I also added labels to a ton of the constraints to kind of give you a better starting point. And then I also added fixed ditches, or you might have heard them called forced ditches or daylight ditches. These are really ditches that should be used when you're in kind of a fill condition that needs a ditch. They help you figure out what the what that ditch profile, a good starting point of that is, so you don't have to guess it so much. So I'll have more details on that in the next video since that's a little bit more complicated. This one's going to be more of an overview of what we have, what I did. So I really have two main types, end condition with a ditch and without a ditch, obviously. And so what I kind of did, I have a screenshot here. I went through L&D Volume 1, Section 300, and I went through all the different end conditions that we have, standards for like safety grading, clear zone, barrier, common grading, and I kind of wanted to just see, what was the most complicated one that we had in terms of number of components that would be needed. And by all means, I'm not saying that what I've set up meets every single situation. This is aimed at a good starting point to handle a lot of the situations. So the main goal I wanted was to make sure that all of the ditch end conditions, no matter which one you choose, will properly connect to each other across drop locations. That way you don't have to worry about, gaps or bumps or breaks because one template didn't have that point or whatnot or component. So here's what I came up with, which is fairly close to what we had before. I've added some more stuff in here, you'll see, but all of them have a graded shoulder component, a graded shoulder point, a force slope component, a force slope point, a force slope ditch, a ditch inside point, a ditch component, a ditch outside point, a back slope component, and then a back slope point. Obviously, if you had more back slopes, you could add those. But one thing I want to call out here is that the back slope point, or really the last point on your end condition, in any end condition we have, the name override is tie. That's done purposely so that no matter what you do, at the very least, you have a tie point across your whole corridor, no matter what template you're using. That way, this point connects to any drop location, and you have kind of that nice seam point that ties into existing, and then you have that one line that you can use, and that can help you start to set up your construction limits. So we wanted to make sure that that was one continuous line, and they all always connected to each other. So make sure you keep that going as you modify these. Some other things in here is just I have a backslope point. You might not see this on every template. This one is just kind of there as a check to make sure that your backslope maintains the required minimum depth of your ditch. So if, once this point, as this starts solving, if it comes in and solves inside this ditch, this height checkpoint, then it will fail and not solve. It's just kind of another safeguard in there to help you in your design. As well as there's a clear zone point that's added. On the old templates, you might have seen it just thrown in the template itself, but I really wanted to just pull that out to be by itself, since it's really just like a guidance point. So as you move this point, this point will stay in check with it. Some other things with the ditch templates, you have simpler cases where you don't need, force slope and then a ditch force slope. You don't need these to change. You just go from your grade shoulder straight into your ditch force slope. In those cases, I want to still make sure that if you are transitioning between like one with the extra slope change and one without, that they just connect automatically. So on the simpler case, all I did was take the force slope point and move it on top of the grade shoulder. That way, they still have all the points are still there, all the components are still there, so the connection still happens automatically. You don't have to worry about doing like end condition transition on something like that. So on the simpler ones, you might see 2 points on top of each other, and that's okay. That's by intent. That way, all the templates have the same components and points set up so that they easily connect to each other. So without a ditch, obviously it's a little bit simpler. I still wanted to try to make the connection between going from a ditch to without a ditch as best as I could. So you still have the grade shoulder point and the grade shoulder component. You still have the force slope component, but you have one force slope component and one force slope point. So this is just one component here. If you, just like with the ditch, you don't need this change in grade, then you just take the force slope point and put it to be right on top of the grade shoulder, and you can go about your day. It works fine. And the tie point, just like I mentioned earlier, the name override is tie. That way, that this point connects to this point always, so you have one tie point. So really, what's going on when you switch between a ditch and no ditch is the back slope, the ditch, and the ditch force slope are what don't exist. So this point kind of goes straight to this point, and you probably need to do end condition transition to take these 2 points to this point. So that's kind of how they're working. I have all this documented in, and this slide I'll go over in the next video for the fixed ditch part. But I have all this documented in our training guide. So if you look at our ORD design training guide 502, I added a Ohio DOT release and conditions section, and this goes over kind of what I just went over. So I have this in here, and I have a whole bunch of notes. It might not hurt to go over that. And then what I did here is I also added a table, which you guys might like this. A table of all the points, all their feature name overrides, a description, what default constraints they have on it, and what labels they have on it, and then just notes about it if you're wondering. So that might be helpful to know I'll look at all these labels that are now on there by default. One thing to know about the labels is some of them you might see a negative word coming at the end. And I had to do that because if you add a height check, like for this ditch depth, on the force slope to the inside ditch, that value is actually negative depth. But then on the height check, that value is a positive. So they need to be different labels, especially if you go and you want to edit the template. If you just want to edit the value, you don't want to edit both those points or it would mess up the template. So I had to have them separate. So that's why you'll see a negative point in there. If that didn't happen where there's not two, then there's no point to have the extra word on there. So I did the same thing for components. So you can see their override names. You can even see what parent they have. And then I did the same thing for without a ditch. So you have a table and a point. And then I did the same thing with fixed ditches, which I'll go over in the next video. So just an overview of the fixed ditch is there's a bunch of extra points in here to help make sure. But basically, if you're in a fill condition, you're most likely above your existing ground. So if you kind of just drew your template in, it almost always it won't solve because this point is above ground, so it never will find ground. So it'll never find ground. So what you need to do is you kind of need to push this ditch down to get to where it would actually solve for ground. So that's what these are going to do. It's going to actually float this ditch down to the maximum elevation that would still solve. So it gives you kind of your ditch profile, and then you'll switch off it. So look at the next video for that, but this one will explain all the points, all the kind of labels I have set up. I had a section on how to edit them and modify it since it is more complicated. I'll go over that next video, but I just want to note that you want to kind of make sure you follow this way for modifying values so you don't mess up the template. And then I have kind of a step-by-step process for how to use those. So lastly, I just want to go over the templates. So I have our template library open, If you go to the grading section, you'll see, there's an old, for all the old stuff that I kind of got rid of. I kept them in there in case you still wanted them, but like things like all these fill conditions, those are getting replaced with a fixed ditch. These fill conditions didn't really check for everything they needed to check for. They just kind of floated all the way down and floated all the way up. So if you still want those, they're there in the old section, but really those are going to be, switched out with these fixed ditches, which, this one, I have some pretty complicated ones in here, but if you look at the difference here, is it keeps this condition like if you're in a cut, and then it'll move into like a fill condition and slide down. So they definitely work a little bit better. And then all of the other ones kind of maintain somewhat the same. I just updated the labels and added the missing extra points if I needed them. So give them a shot. Let me know if you have any questions on that. Hopefully you find them more useful to use.